Okay, so we look at our R as quickly as possible. We are going to look at functions, but before I look at the functions, there was this issue that I just sorted it out with Polly a moment ago. So let me demonstrate what that means. If you have a data set, if you have a data frame, and you want to add, let's say, columns to that data frame, how do you do that as quickly as possible? So let me come down here. I just want to create a data frame of 2 columns. Data frame would definitely have 2 columns. So I'm just going to call it anything. So DD. So I'm just going to say, and then it's going to be a data frame, data.frame, like this. Maybe if you are not conversant with how data frame is being created, you should do it the systematic way, how it is being done. So I'm just going to say my first part of the data frame is going to be, so I'm just creating it right away. So I'm going to use the run if function so that I'll be very fast about it. So I have 10, I have 2, and I have 8 here. So I'm going out of that. I'm going out of that to also go and create another data frame. So I'm using the C function again, and then I am also coming here to say I'm using the run if function as usual. So what is going to happen is I have my 10 as usual, this time around 4 as my minimum and 7 as my maximum. Alright, when I finish, I just run it and the data frame is created right away. So if I print it, you can see the data frame here, even though I didn't give them titles. The data frame is here. So I automatically gave them titles. So what I have done here, I can actually add let's say column names or whatsoever. That will be a topic on another day. What I have simply done here is I just decided to pick whatever that is here. Let me pick from this place out there. Oh, sorry. Okay, so I'll just come here because I want the titles to be there. I don't want it to be too confusing, so I just put that outside there. Then I also come and copy the whole thing here. I wanted to say that you could just create it right away, so that will be S equal to that. Then if I come here, I have another, maybe C, and then that one too is equal to just put this there. So of course, so I have my 2 data frames. They are supposed to be closed to 2. That's where you see when if you are writing your code and you see all those things over there. So the data frame I have here is actually S and then C. So if I run all of them, the data frame is created. That way, if I print DD, you see that I have the data frame here with headers. One of them, the header is C. The other one is S. Now, how do you add a column to this data frame I have here? This is the name of the data frame, DD. That's the data frame we have created here, DD. How do we add a column to it? You see that when you come to the DD and you do like this, the names of the columns come down. It tells you that right after the dollar, whatever comes there is a column. So if you want to create another column, then you first of all have to give that particular column a name. Maybe you want to call that column F. Alright? So you have to look for the variables or the data entry, the data point for that new variable, or what is it? That new column that you have just created. The fastest way to do it is, now you have created the column, but for now it's empty. It's empty. There's nothing in it. So you need to put something in it. To put something in it means you need to assign something to it. So if you are assigning anything right now to this particular data frame, you are simply saying that you are assigning it to this column. everything comes to this particular new column called F. So I could just go there and then I'll go and use my vector sign here, or I'll just paste whatever that I have copied already. You see that whatever I have there, now I am simply saying that when we run this particular code, which is going to print 10 different numbers, 2 minimum, 8 maximum, those numbers are going to form the third the third column of the data frame, which will be called F, and that's what it means. So let me just change these variables here, and I will say this, and then of course say this 15 to distinguish it from the other one. Yeah, this one too, it was just too unique. I should make here 4, maybe make here maybe 11. So now if you come and run, if I come and run all of them again, if I now print the DG, you see that I'll have 3 different what columns. That's how we add a column to a data frame. Just like the same way we can also remove the column, we can add the column. If you don't want to do like the way I have done, the second way could have been you create this one as a vector somewhere sitting. So for instance, I could have just maybe I copy this from here. So that could have been a different data, or that could have been a different vector sitting somewhere on top here. So I could call that the vector maybe G or something like that. Then I just put this there. So remember that all the things at the left hand side, they are variables you are creating. You can give them any name. So when I run, I have printed this data, but I have packed everything into what we call G. So I have a data frame already, but I now want to add a column, and that column should be made of the data that is found in G. So to be able to do that, if you have the data frame already seated like this, then you just simply come and add your $sign to it. Then give the name of the new column that you want to add. Already I have a column S, C, and F. So I want to add a new column. What is the name of that new column? It must necessarily not be the name here. It can be any name at all. It's a variable you are creating, so you can give it any name. You can decide to make it R whatsoever. So if we decide to call that particular column T, that's a new column. So we now look for where is the data that is coming to be in that new column. All right, so we just go here and say, okay, we've already created that data in a vector, which is found in G. So come here and then do G here. When you run it, everything that is found in G will be packed into the data frame in this new column called T. And that is how we do it. So now if I come to print the new data frame, we should have 4 columns. And you can see how it's been added. So that's how we keep on adding columns to a data frame. It's a little bit different from cbind and rowbind. The cbind, you already have the 2 data frames, and you are adding maybe part of the columns or part of the rows. That's what we use cbind and then rbind respectively. So this is how it is. So mostly the questions people will ask you is that there's a data frame, they will ask you to create a data frame, then do some mathematical operation on that particular data frame and add that mathematical operation as a new column. So this is what you do. So let's assume that I wanted you to have calculated the percentage of each particular column and then add it as a new column. Or I wanted you to have looked at the mean, or I wanted you to have looked at any other variable at all. I wanted to divide one of the columns there by the other. So for instance, if I have, let's say this is my column S, I could divide it by the next column. So I could say DD, then I bring my $sign again, and then I could divide it by this. When I do this and I divide it, it's just going to come. So you see that this is the result. But if you want to add this result as a new column, so that we can know that the new results or the results of dividing column S by column C is this. So you create a variable and assign the answers to it. So you could create a variable like W, and then you assign whatever that you have into W. Remember, equal sign can also be used as an assignment operator. So I could just do like that, and when I do like this, So now the whole thing has been packed into W. So I can now come to that same data frame and say, and I want to add I want to add this particular resource I have here. So to do that, I have my W seated, which is already containing the resource here, and I want to add that resource as a new column in this data frame. So I'll just come and write the name of the data frame, put a $sign to it, and then ask myself, the new column, what am I going to call it? Is it W or a different name? If it is W, put it W there. Then you say, okay, if it is W, where is that new data that is coming to form that column, the new column? Okay, that data or that particular data points are found in this W. So you come and then write the W there, and that's all. When you run it, then you have added another column to it like that. So you see that we now have another column like that. So it's basically like that. And there are instances that you may want to add the column bar. Okay, let me do this last one. What is it? Let me do this last one, and then we see how that is going to be. So let's assume that we want to add names to something. So we could just say that's names. So the names of the individuals. So we can create a vector. We can create something like a vector of names using the letters. So we just say this, and then we come here and use letters. Maybe we want the capital letters, and the capital letters mostly, I said, when you do, bring your curly bracket. You want from the first letter to 10, because they have to have the same number of rows. So when you do that, if you run it, the new one, the ABCDR to 10 has been packed into this vector called n, or this variable called n. So now I want to add the n into the data frame as a new column. So I'll now have to come and write data frame, and then what's the name of the new column that I want to add? Maybe I want to call it capital N. So, but let me do something small and see whether it will work. Okay, so here, and then put it this way. Then I'm going to come here, this, and put n there. Let me run it and see. There is an error somewhere, incorrect number of subscripts on matrix. Okay. Just a minute. Let me run it again and see. I'm trying something to see. The number of items to replace is not a multiple of replacement. Okay. I wanted to actually add it and then put an index. Okay, let me print n and let's see how many are they. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we could have added it, but I wanted to do something. So this one works, but I wanted to. Okay, so now let me do it this way. Let's say I have this and this. So I'm just going to come in the middle here and then do this. Then I have 1. Okay, so I wanted to give it an index in such a way that when it goes to occupy that particular place. But maybe I'll get that later on, and then I will let you know. You can add the column to go and occupy a particular position. Maybe you want to add it to be the first column. So you need to, on the data frame, you need to indicate that, okay, I'm adding this column, but I want it to be column 1. So you have to identify the index. And this is what I was trying to do here. I was trying to, say that when I'm adding, it should go and occupy the first column. And so I decided to use this to be able to indicate that, but it's not working. Well, that's not what we are looking for today. I just wanted to let us know how you can create a data frame, and of course also to be able to add or remove or whatsoever. Okay, so that's just by the way. Today we are going to look at.
Please, can
Yes.
you erase the last part? Maybe
Come again.
the last part, that
The last part. Hey, hey. I can't. I can't hear you.
I think the internet is.
Yeah, now
It's
you are
okay.
clear.
I was saying, can you erase the last part so that we wouldn't confuse ourselves?
I'm finding it very difficult to hear you.
I will send you a WhatsApp message now.
This red message. Or you say you send me a message.
Yeah, I'll send you
Okay, then that will be fine. Okay. So now let's look at functions in R properly. Where is this gentleman? He's not around. So functions in R is what is it? Is one of the the most important aspect of coding. And most of the things we all have, most of the computers and whatsoever that we have, they are functions people have written. People have written functions, and when you have a set of functions put together to perform an action, we call it a package. So we have several packages that we can put in there, and then inside those packages there are functions. You put the functions and be networked, and then we are able to use that package to do ABCD. On our phones, everything that we are tapping on is a function somebody has written somewhere. And that's why in R there are inbuilt functions, but there are instances you also want to like have your own function. For instance, when you go online now, we have several calculators people have built. Population estimators. You can look at if you are doing your research, and then let's say you want to your sample size. There is a calculator as to how to be able to sample. Now, how are those calculators and everything built? That's what we want to try and then have a basic understanding of all the odd things. Now, there are a lot of inbuilt functions in what is it in R. I just decided to create a vector here, and I call it XX. Now, I started with what is it? Any what is it? Thing that is starting with A. So when you put A here, we have a function called any. Any. Any means I'm just looking for any number around here. I'm looking for any number around here, and then and then that particular number I want to find out what is it. So if you come here, the first one I say any number from this particular vector that is less than 50. So it's going to return me a boolean. You run that, it's going to say true. Yes, there is a number here that is greater than 50, or that is less than 50. Okay? Then we can also say, is there any number there that is greater than 50? Then
Hello. I was saying, can you please delete the last code you were trying to add and it didn't work?
okay.
So that when you copy for us, when you copy the script for us, it doesn't show.
Okay. Okay. All right. So yeah, what is it? I get your message clearer now. So where was I? Yep, it was this last one. So I take that out. So I just needed to have come here and say DD. Then I'll just put my dollar sign there. I think I've already done that. If you don't take time, I might be adding it twice. I'll do it, but I'll not run it, so it will just be there. So I just do this and go and say end. That's all. So that was the code. Now let me get back to this. So as you can see, we have plenty inbuilt functions. So I could use any. The any will tell me whatsoever. So you create any thing, or like a data frame like we just created right now. The data frame we just created right now. We could just check we could just say any. And when we put any, it's asking us for. So we are looking for DD. And then we want to find out in that particular DD, we are looking for this particular column. Is there anything in that particular column, any number in that particular column that is greater than 20? When we run it, it says false. It means there's no number in that particular column that is greater than 20. So some of these things, they are preliminaries. That tells you that this is how my data is looking like. This is how my data is, and so you can be able to apply other functions. So you use any. Any is an inbuilt function. If I come here, all is also an inbuilt function. So all means I am checking the entire set to find out whether at least there must be all of them. Are all the numbers there greater than 50? Are all the numbers there less than 40? When you run that, it gives you a Boolean. So the point I'm trying to make here is that we have inbuilt functions. For instance, I could actually check most of the inbuilt functions. Let me try most of them today and we see. So we could check something like mean. Mean is an inbuilt function. We're trying to find the average of, let's say, XX. You put the XX in it. When you run it, it tells you the average is 30.7. If we want, we could find the summary. Maybe summary may not work because it's not a data frame, but let me try and see. But it works. So it gives us the minimum value, the first quartile, the median, and whatsoever. So that's the summary too, is also an inbuilt function. We could look at the median. So the median is there, then you put your XX inside, then you see that we can have the median is 25. We could actually look at the first quartile, or okay, the first quartile we've already printed that, we don't need that again. We could actually look at other inbuilt functions which are there. We could actually change the whole thing to, let's say, factors. We could change all of them to percentages. We could check their correlation. We could check whether there's a relationship somewhere. The same way we could do that for the data frame, which I think in our last tutorials we actually looked at that. So these are inbuilt functions that we have in R. But trust me, most of the inbuilt functions, they may not be able to do you exactly what you wanted. Exactly what you wanted. So there are instances, the way your data is, you have to write your own function. All right. If not, you won't be able to get a specific function that will do whatever you want your data to do. And you know, in ordinary mathematics, when we write something like, when we're doing functions in elective maths, we say a function, we always say f, and then when we put like this and put something here, it means f of x. We're trying to find the function of x on maybe something. So most of these functions, they are just like formulas. They are basically like a formula, like we all know, and the formula will simply do whatever that you want it to do. But the difference between a function and a formula is that a formula has already been formulated, and then you are now using it. A function, you determine how the variables are going to work. Okay. Now, the basic syntax in function is that a function must have a function name. So let's say I have a function, so it must have a function name. So it has a function name. That's the first thing. And then you are going to assign whatever function that you have to it. So the function name, it should be followed strictly by the word function. So you have your function there, and then after the function, what is followed is what we call the variables or the argument. So you could put whatever argument you have there. It could be argument 1. It could be, you could have argument 1, argument 2, in that order. Now, when you have finished those arguments there, you need to come out with what we call the body of the function. And you use this curly bracket to be able to do that. You open the curly bracket or the braces, and then you enter. Now, this is where you are going to build whatever you want this function, the function name, to do. So you are now coming to do here, maybe you now want to say that argument 1 must be multiplied. Let's say it should be multiplied by 2 and then added to argument 2, maybe all divided by, or argument 2 multiplied by 3. And so when you have done this, you need to assign it to a variable. So you could say the variable is d, and then we could just say like this. So we've assigned whatever that we have built here to d. And then when we have done that, then we come here and then we return the function. So what are we returning? We are returning whatever that we have built here. So the returning always gives us the opportunity to know whether the function has worked well or not. We have built this function here using the argument around here, and then we pack everything into this function name, which is there. Now, when we finished, anytime we now want this function to behave the way that we ourselves have created, we now just bring the function name, and that's what we call to call a function. You bring the function name like I have done, and of course, when that happens, it will ask you to put in your argument 1 and then put your argument 2. I think this place is 2. And when you have done that and then you run, it will print out whatever that you wanted it to have done here. Is this explanation clear?
Yeah.
All right. Now you are alone, so it's much more. Come again.
Mohammed.
What is it? He has. I don't know. I can't find him. He joined, but I'm sure I don't know whether the network or something came up. So that is the basic syntax of functions. Up to this place, I'm going to do a block comment so that it's not part of any code. So you press Ctrl, Shift, and C to comment all of them out. So now, my first example, let's say that I want to calculate the area of a rectangle. We know the area of a rectangle is the length times the breadth. If my mathematics is still better. So what I do is I say area of a rectangle, then I create a function. Obviously the functions will change. And these are my arguments. My argument 1 is the length. My argument 2 is the breadth. Then I open my curly bracket and come and say that, okay, I am looking for area. And then in that case, I am describing the body of the function. So the body of the function is that I am looking for an area. It says it's a variable, so you can give it any name at all you want. So you come here and then you have, let's say, your L times your B. So it means that that's how you want the function to behave. You want the function to behave in such a way that anytime you have L and B, it should calculate something called area. So return that area for me. So what I'm simply saying is that return the area for me, like anytime I give you the values for L and B, you should calculate an area for me. So when I do that, let me take this out and then you will see something, it doesn't confuse So when I do that, if I run it, the function runs properly. But at this point, you will see anything. So you should now remember that everything you have created has been put into this particular function name. So you come to what we call the function. To call the function means it's not like where you and I will run a function and then it will just print out. This time around, no. It will ask us to pay to make the input. So you come and say your area. That's how you named it. So you see that when you come here, you see that it tells you, you see on top of it, that you are supposed to bring an argument of L and B. That's what you yourself have created. So it means you are looking for two arguments here. So if I put here 3, and I put comma, and I put, let's say, 4. All right. Now, if I run it, it will calculate 3 times 4 for me. And you see that the answer will come as 12. That's basically how functions are being created. I mean, we can do all sort of things and add other things and whatsoever. This is the basic way of creating a function. Now, I have another example here. Let's say that I want to calculate the BMI of people. I want to calculate, okay, sometimes when I'm typing, I really make a lot of sense. So let's say that I want to calculate the BMI, or I want to have, you are a nurse, you want to have a BMI calculator in your, in your office, on your laptop. So you build a small function for yourself and be using it to calculate your BMI, depending on what other parameters you want. You know very well that BMI is, you are looking for, just momentarily, I keep checking to see whether if some people are, are there right. So, and we agree that BMI is the weight of the person divided by the height square. So what we need to do is we need to build a function like that. Anytime we have the weight and the height, we just put it there. It will go ahead and tell us the BMI of the person. So we'll build the BMI calculator. So we'll say, we just begin by the function name. So I have BMI, right? Because I've already done it, let me leave that as aside. So we have BMI calculator. So that I'm just want to, and then that's the name, that's also the variable. So we say a function, because we are going to create a function. Okay, a function should come. So what are the arguments? So we are looking for the variables, we are looking for the individual variables that require entry. First, we are looking for the weight. And then we are looking for another variable called height. And that's all. When we get the weight and the height, any other thing will work. Now, when we have finished with all the variables that we need to form our, our calculator, then we come out, we have finished with the function argument. We come out with the function body and now describe how we want the function or the variables to interact. And that's it. So we want to calculate BMI. Okay. So, or I could just give it BM. So in that case, I'll say I'm assigning how the functions will work, and I'll say that okay, I want it to be weight divided by h square, height square, and then in programming, square is just you press your shift key and then 6 on your keyboard. You will see this there, and you put 2 by it, and that's how it is. So I come here and say return, then return what? BM. Like this. I finished. So when you finished, you run this and it is now sitting there. So anytime somebody now come, maybe people have come with their weight and their height. If they give it to you, you just input it into the calculator. And by doing that, that's what we call to call in the function. This is done everywhere. In Python, this is all that what is being done there. You write a function, you call it. You write a script, you call the script, and whatsoever. And that's the basis of what we're doing. So I'll now come and say I'm calling the function called BMI. I have the BMI calculator here. And when I do that, just like any other function in R, which when you write the function, the argument always come on top. This one too, you see the argument on top, asking you that you need to put in W and H. You need those two variables. So let's say the person's weight, let's say was 60 kilogram, and then the height is supposed to have, I don't know, I know you're not tall, so you may be 110 centimeters. So when you put the two figures, that's all. You just have to run it through it. So look at your BMI. So anytime at all, you can always. So if another person, if I want to calculate another person, the same way, I just have to bring the calculator. I just have to bring my BMI calculator. So I have my BMI. Any of them. And then it tells me that I should bring the weight. So my weight is 66.4. And then my height, I'm 5 point something, 5.4 inches, meters. I don't know in centimeters how that would be. How much would that be? Is it 150? Okay. Come again.
In calculating BMI.
Yeah. They use meters or centimeters? Meters.
Yeah.
Okay. So in that case, I think I should reduce this to if it is meters. You are 1.8. 1.6.
Yeah.
So in that case, if I run that, so that's 23 point something. So you see, we could have gone ahead to also write a function to find out whether if your BMI is like this, are you obese or you are not. I think that should be an assignment. A function to find out if the BMI is this. Are you obese or not? We can use for loop to be able to do that. Okay, so in that case, here I would have been, if you are 1.6, I should be 1.8. Yeah, because I know I'm way taller than you. I should be 1.8. So I could have calculated and then look at the difference. So somehow it means that somebody is heavier. Okay, so that's how we are able to calculate or to be able to write a function. Now, before I go ahead, it's like, I don't know, let me check whether Mohammed is there. Mohammed, did you hear my last part, the explanation to functions?
I heard a part of it, but not fully.
Yeah, so you notice that if I have a vector like this, I just created a vector like this, we can actually do all sort of things on the vector using functions that people have written, and they are there. So like, for instance, this is any is a function. So any means you can just go inside your data and you want to find out where whether there's a value that is less than 50. When you do that, if you run it, it should return true. Yeah, there is. and then in that order. If you come here, we can find the mean. This particular mean that we always just write and bring the data and then to calculate the mean right away. Like here, somebody has written that function and it is there. The summary, somebody wrote the function and it is there. Like the median, somebody wrote the function. Those ones are called inbuilt functions. Now, when we come, we ourselves can write our own functions and they will behave exactly like how the inbuilt functions are. And that's what we are just doing. Now, to be able to do that, you need what we call the function name, then the function argument and the function body, and then the return function. Now, the function name is what is the name of the function that you want to create. Sometimes it's good to give it a realistic name. Maybe you want to create a function to calculate the performance of your students in class. So you can say performance calculator or academic performance calculator. That's going to be an assignment anyway. Then we have, when you do that, you bring the word function, and then, but you know, when you are creating a function, obviously you are going to use variables. You're going to use different variables because you can't actually use numerals. Numerals are constants. So you can't use constants to be able to create any function. It won't work because you and I don't have the same weight. So if you use 6, 5, 4, it means you're going to stay with those figures forever. That's why we use variables. And the variables are the argument. So depending on how many arguments are going to form part of your function, then you put those arguments here. If there are about 3, 4, 5 of them, put them inside here. Follow exactly by the function. Now, we call that one the function with the variables. Now we have all the arguments. Then we follow by the function body. The body is where you actually write out to interact. How do you want argument 1 to interact with argument 2? And in that order. So we can say, maybe I want argument 1 to be multiplied by 2, plus argument 2 to be multiplied by 3, and everything sum up. Alright, so when I have finished, then I will say that, okay, I have finished, this is how I have finished it. But to show that you have finished writing how you want the argument to interact, you bring the function called return, and to return that variable you have created called d here. When you do that, it means you have finished with the function. Now, when you run it, the function is there. You can now come and call the function. To call the function means to run the function. It will ask you to put in those arguments, and it will go ahead and calculate or do whatever calculations you want to do. And that's why we're trying to calculate the area of a circle. What is it? He's not around again. Okay. So, Paulina, what is it? Your first assignment. We've looked at the two. We've done how to calculate the area of a rectangle. We've just looked at how to calculate the BMI of all of us. Then, now the next thing is, I want you to also write a function to calculate the area of a circle. But you see, Paulina, before you start, let me show you. Let me tell you this. In data science, most of the things that we are seeing, they are real life things. So always relate whatever we are doing to real life example. For instance, I could have asked you, I want you to calculate the surface, different surface areas of the first four plates that you are using in your house. You get what I'm saying?
Yeah.
Yeah. You see how sometimes they can ask a question that will look a little bit. For instance, if you're working in an industry and you were supposed to be the data scientist, because you will be the one that will be coming out with the dimensions, like packaging. Somebody want to package sugar or whatsoever. You should be able to calculate. And then those are the things, you write those functions to do those calculations. And those packages, they come in real life. So you translate whatever we are doing theoretically and look at it in that manner. So instead of me saying this, I'm going to now ask you the question properly. I want you to write it as a question. Calculate the surface area of the 4 commonly used plates in your house, in your home. So, I mean, write a function like that. So write a function that can automatically calculate the surface areas of the 4 plates that you use often, their sizes. So next time, you get it?
Yeah.
Great. What is it?
Sorry.
Your network is worrying you a lot.
Hello. My network is very bad. I haven't changed location.
Sorry about that.
It's very bad here.
I just gave.
Don't worry. Maybe on YouTube, I'll watch it on YouTube.
Okay, no problem. Okay.
Thank you very much.
You're welcome. So when you finish, let me know.
Yeah. I have finished.
All right. Is it working properly?
Yes.
Great. So I was expecting that you were going to do this. So you have your plates. What is it? You have the plates with different sizes. Let's say you have, let's say the place, and then they have different sizes. Let's say their radius is what that is all that matters. So one of them has a radius of 3, one has 5, and one may have 1.8. Okay. So because I'm using more than one, I need to concatenate it. Okay. So you have those places around here with this particular whatsoever. So you come there and say you are calculating the size, the surface area of plates. So that would be the name of your function. So let's say you are looking for the surface underscore area. So we're going to build the function, and we say here is our function, right? So what argument do we need? We know that we are looking for, how do you represent pi in what is it, in R? So what did you do? So in this case you have only one variable, which is R, right? So we come out there and then we say, okay, this, then we enter, and we say that our area we are going to calculate is equal to what is it, pi r squared, and we know that pi is 3.142. Then you multiply it by r squared, so you have come again.
What's the value of pi?
Is it not 3.142? It's a constant. So because of that, you don't need to bring the pi there. It's a constant. That's why I was saying that, yeah, it's a constant. So you just leave it that way. So if I come here, then I'll simply say return what? A. And that's all. So when I come, I can just do that, and then that's all. So the next time, if I now want to calculate the different plates, I will just call the function, so surface underscore area, and you see that it requires me to put the radius. So if I put the first plate 3, it should calculate automatically that the surface area is 28 point something. Then I can do that for the next plate. I can do that for the next plate, and then that's all. If you got that right, then that's okay.
No.
Come again. It's like Mohammed had joined again. Oh,
Yes.
okay. I thought he was off. Okay. So
I'm with you.
Okay. So how did you build it?
I don't know. I don't know.
Come in. Okay. Then you will do another one. So once Mohammed is there, I want you to do another one. You have a room, and you want to put, let's say, 4 tables in that your room. So you want to write a function. Okay, you have a room and you have some tables. You want to find out. Let me put it a more practical way. Somebody is trying to construct a restaurant, and he wants to have some tables that are supposed to be put in that restaurant. Okay? Some tables are supposed to be put in that restaurant. Are you writing up?
Yeah.
So, if you write a function that you'll be able to use to know that if the room size is this is the total number of tables that can enter. I am assuming that the room is rectangular. So now, what is it? Let's do it together, and then we'll come and do this. So we have okay. So if the room is rectangular, so we are going to calculate. I'm thinking of what name we should be giving to the variable. So we have, let's say, let me put it like a restaurant. Hey, restaurant, I can't spell. Maybe after I don't eat in a restaurant. That's my problem. So I have a restaurant, and so I'm going to say a function. You notice that when you write your function, when you start writing function, you will see that okay. So I'm going to have something I call the L, comma, and then B. That's what I'm assuming. So the length times the breadth. That's the area of the. Then I could also have another variables, or I could just leave it here, and then I can go and then do whatever calculation that I want. Okay, so if I come here, I'm going to do like this and come down here. So I want to know, first of all, I need to calculate the area of the room. So I will say area of the room is going to give me, let's say, L times B. That's going to give me the area of the room. But if I have the area of the room, I am assuming that each table has a surface area of 4 meters square. 4 meters square. So we could have actually added it as also a calculation. So we can say number of tables, then we do this, and we will say that it's going to be the argument divided by 4. It means that when we have the area of the building and we divide it by the surface area of the table, we'll know how many tables can enter inside. Am I making sense? Then we come here and say return number of tables, and then we have finished. I think there is unwanted material here. So when I come, I just run this, and that's all. So next time, if I come here, then I will simply call the function, which is maybe the restaurant. It asks me to bring my length and breadth, So my length and breadth is, the length should be about 15 meters, and then the breadth should be about 12 meters. That's a standard room. A standard room is actually about 21 by 16. That's the size of my office, 21 by 16. By 16. When I do
Hello.
that, it will, yes.
Please, do we have an undo function in R?
Undo
Function in R.
undo on, yes, it's the same thing like the way we have in what is it, Microsoft.
So Control Z.
Word. Control Z.
Oh
is
yeah,
undo.
it has worked.
Okay,
Thank you.
All right. So, Paulinho, have you seen how the thing works? It means if somebody wants a restaurant where he wants smaller tables, like those small tables that maybe 2 people can sit on, which is like 4 meters square. If the person should build a restaurant of the room size of this, then 84 tables will enter inside. If the person, so you would now advise the person as a data scientist that, okay, if you want to have, let's say, this number of if you want to have about more than 100 tables in that particular room or in that restaurant, this is the size of the room that you should build, and it will fit properly. Okay.
Yeah.
This thing, let me also give you, now this is your assignment, the 2 of you, but it will be more appropriate for Paulina. Paulina, what do you ladies, you like cupboard a lot? Huh? Is it wardrobe or cupboard?
Wardrobe.
Huh?
Wardrobe.
Okay. You want a carpenter to design a wardrobe that should be partitioned into what is it? You want it to be partitioned in a different, of the same size. The partitioning should be of the same size. I want it to have, let's say, 16 partitions. I mean, right? And then each particular partition should have a specific size in such a way that it will be able to contain maybe your shoes, and some will contain your cosmetics and whatsoever. Can you write a function that you will know that, okay, if I have this type of this size of a wardrobe, this is the total number of partitions that I can have. If you look at this thing carefully, you can do it. And when you have done it, I'll then let you know how people are able to build a box, and then anything will enter there, how they calculate that, okay, this is the size of the TV, this is the size of the box. So, like car tires and everything, people can build car tire in America and bring it here, all the rims, it works. This is what they call standardization. In standard boards, is not anything. There are functions that people have built, and that function is being used everywhere. Well, if the car should have this rim, so like the area of the circle we just did, I could just give a question right now and say that, okay, if you have a car and the rim size is this, so what will you do if you want to, and you just put it in there and then it will calculate for you. Should we go ahead, or you want to try? Okay.
Let's go ahead.
Okay. All right. So now we've calculated the BMI. We've done the circle. Okay. Now, what we have been doing so far, it has been like we have the argument that we put there, and then we can do whatever that we want. So what about if we want to build a function that can also we don't have a specific a specific value. but we can give a range of values to be able to be working with. So depending on the value that you give, it can actually calculate the range. So you see that here, I am looking for where I have highlighted. I am building a function that, even though I have not given the specific argument, I can use for loop to be able to build that particular function. Let me finish before I explain it quite further. Let me hashtag here and say function with for loop. So what I do is I have my function and I have my argument, which is, let's say, a, and I'm saying that for this particular item in 1 up to whatever that I have in a. So it means that if I give a 2, it means that from 1 to 2. If I give a 100, from 1 to 100, then calculates whatsoever. Then it's going to iterate, pick the values, and come and calculate and return it. So if I say 10 right now, if I do the whole function, you see that it's coming to print the 10 variables that it has calculated. So that's how this one, how it works is, if you are combining for loop with, so let's say, like in the case of where we were having different plates and we wanted to know their sizes. So Paulina has different plates. I told you that I will get to that example. You have different plates of different sizes, and you want to know how the sizes are and how they differ. All right. So we can actually say the function is called plate sizes. Plate underscore sizes. So I'm going to do this, and I'm going to say a function there, and then put the argument there. Because I want to use a for loop, I just put the argument there y, just 1. Okay, I can just put the argument there y. Then I'll come and open my body of my, and then I come there to say maybe 4. Then I say that anytime you see 4, you are opening a bracket. You are now looking for a size, in what? Y. But y has not been given. Y is what you are going to give, and then it will return something for you. So you can say, maybe if you give y, if you leave it like this, if I put here y, it means that I am looking for a specific number which will be represented by y. But if I say 1 all the way to y, like this, I am saying that from 1 to the number that will represent y. Okay? So when I have done that, finished, again, I have to open my braces again and then say whatever that I want. Now I come to open it again and I say, okay, now I have found that particular value. If I find the value of the size of this particular length, I should come and perform some mathematical operation on it. Then I will say, okay, size, in this case, let me now put it S is equal to, and we know that we are calculating the plate size. So obviously, it's going to be like a circle. So we use the constant called 3.142 multiply by y. Multiply by size. Size is the item we are looking for here. And then but it is pi r square, so it is size square. So I'm going to put here like this and put 2 by it. Okay, so now when I have done this, the last thing is to return the function. So what am I returning? I'm returning s. That's the last part of it. And when I do that, I can run the entire code and it runs properly. Okay, now when it is run properly, then I can now come here and call the function. To call the function means I just say the plate underscore size, then it will only ask me to bring my y. So if I bring my y as, let's say, as 6, it means I have 6 plates, or I have plates and the sizes ranges from 1 up to 6, and I want to calculate all of them. So if I run it, it will print the 6 plates and their sizes at the same time. So if you run you see that it comes to print, but this print just 1 alone. It's supposed to print more than that. I don't know where I got it wrong.
It's even printed the pi.
Come again.
It printed the pi.
It printed only the pi.
Yeah.
Okay, then let me see whether the whole function was properly run. Okay. Okay, so let me say plate underscore size is asking me for y. So let me put y there 4 and then run it to see. I think there's something wrong somewhere. I don't know what it is. Okay, let me see. I don't know. Let me see if I can fix that as quickly as possible. Oh, this is not a multiplication. Okay, let me change this and see something. Come here. And then I'll run the whole thing again, because I expected to. No, I'm coming. Let me run this second code and you see something. This is how I expect it to appear here. It's supposed to appear this way. Okay, let me take this out. And then I'm coming to run that again and see. No, still. Well, what is it? I won't waste much time on it. I think I will get to know where the problem is as quickly as possible when I sit on it to check where it runs all right, but I expect it to calculate more than 1. Maybe I got the syntax somewhere wrong, and I can't figure out, because it's not an error. That is why I'm not able to figure where I got it wrong. For a function y for si in 1 is to y
I for the what is
Come
the
again.
the first
The constant.
what is the what is the one no the
The what?
four
The 4.
yes what is the one is one no
And the SI.
yeah
No, that one then it doesn't really matter. Anything at all. If I leave it here like this, like what is this? Like this. Let me run the whole thing and see. It's the same. But look at that function and this function and see whether there's a difference. Here. I don't really see the difference between them. So let's assume that this was the y, or perhaps I might have used y for something and that y is hanging there. So let me say A. Or let me say V, a small v. Come here and change to V because I can't specifically see where I get it wrong. No, it's still 1. Okay, then okay, now let me leave it that way, and then so that we don't waste a lot of time. But the point where I was trying to make is that if it were, let's say this is the same code. It's the same code. The code I have here is the same thing on top here. There's no difference.
you did
So let's assume that we're having the plates, quite a number of them, and let's say there are about 10 of them. So if you build the function, then you have, and then you just don't give, you have given only one argument, which is A. But when you are saying that you are looking for 1 up to the A. So if the A is 10, you are looking for 1, 2, 3 up to 10. So you want to calculate up to like 10 different plates, which are having sizes from 1 up to that particular. It doesn't really have to mean that it should start from 1. It could actually start from 4. You could actually say 4 to A. All right. So if you do that, if you come here and then you run the whole thing, the function should run properly. And then when you call the function here and run, it should print, you see, what is it? The different sizes of the plate for you. And that's what I was trying to say. So you can actually use for loop to be able to, print functions of that nature. Like, you see that I have another one here. In this case, I have only X. So let's say that I have the plate sizes. The smaller plate is, let's say, it has a size of, let's say, 3. And the bigger one has a radius of, maybe let's say something else. So you build the function in such a way that when you run it, it's there. Now you come, this is the bigger one, the bigger plate, and then you can actually just run it. But in this particular one, the function here, I've decided that after we have finished this one, we are using the for loop. We can actually use the concatenate function to have more than one of the variables. Let's say that we are having just a plate, or we are having just some range of values, and then they differ in some way. So we want to go through all of them and calculate them in a particular function. I'm looking for the realistic example that I'm not getting as quickly as possible. But in that case, when you have the variable, you could actually say for I in 3 is to that particular variable, which is x. Then you now do your calculation, but in this case, you use the concatenate. First, you are going to print the i's. Second, you want to print the I square. And then the third, you want to print the I times 3. So for instance, let's say the I was the size of the plate. You could add here 3.4. So it means the last column will be the size of the plate. And then this one could be the, let's say, could be the weight. It could be the weight of the plate. And the first column could be their radius. So in that case, when you run the entire code, and then, so if you fold this up, you'll be able to realize that you have, first you have the radius, and then the second you would have their weight, and the third column will give you each plate and maybe their volume or something like that. Are you following the argument? Yeah. So in that case, you actually use the concatenate function, like we have it around here. Now, the last part before we part company, time is actually gone. We want to create a function without an argument at all. All right? There's also something like that. You can create a function, no argument. You notice that in R, if you put something like this, where do I have space? Okay. In R, if you put something like, let's say, data, and you bring yours, this particular one, that's a function without an argument. You are saying that you can put in something here, but if you don't put in something here, what is it? That's a function that is almost like taking the entire thing. No specific argument has been given. So we want to see how we can create a function without an argument. And to do that is always, the easiest way is like, what function are you creating? Maybe I want to create a function that will have, what is it? The exponential growth of people. Okay? Or you want to look at the exponential growth, the population growth of different people. So I could have here and say I have, I've already written a function about population. That's why it's giving me this. So that's the function. I come there. I'm going to just build in the function here. And because I want it to be empty, I just leave it like that. Then you enter. Okay. Oh no, I'm not entering. I'll do this. Open my braces. Then I can now use either while loop or for loop or any statement, and then to be able to loop through. So I can say, let's say for, and then you just bring this for, what are you looking for? For P, if it is for population in, what kind of population are you looking for? Maybe, or for P in, or for a mark. It can be anything. And then you now give the range. The range, you can say, you can actually also write an algorithm that can do this. So let me use this one for now. We can say for, let's say, from 2 up to, let's say, 12. All right? So we are looking from 2 up to 12. So you have to come out of it, open another braces again, and now bring in your argument. So you are simply saying that we are going to print what? We are going to print our P. But we could print our P. Let's say we can print our P here, and that's all. So when we run that kind of function, it runs properly. We can now come down there and say, and bring call our function, which is population. When we do that, it will simply ask us to enter any maybe any value at all, or anything at all, or we can just run it that way and you see what will happen. It will print from 2 up to 12. It's going to print from 2 up to 12. If we had, because this place, we didn't add any mathematical operation here where we wrote the print. So if we had added any mathematical operation, like let's say, if we had say p square, p raised to the power, let's say 3, and then we run the function again, you see that it will print different values. So what it will simply mean is that anytime we call in that particular function, population, it will just print out the argument for you. Mostly, I haven't explored much how we use empty functions, but I just wanted you to have an idea of how it's being created. This is another empty function. You can create it with, and then it will just print I square for all the values for you. Now, I also want to emphasize that you can actually create the functions, and then, for instance, you are looking for, this is an empty function that I am creating, but in this case, you are looking for a score in a random set of numbers. So you are actually creating 15 different numbers, with the lowest being 3, and then this, and then you say print the score and divide it by 2. So anytime you call that function, because it's an empty function, it should just print those values for you, and then the function, the values are there. Now, there are quite a number of them, but I have to jump some of them because I'll be giving you this. So there's this a variable. You could actually have different arguments. That's the first part we started. After that, come and combine the arguments, have whatsoever. So the next time, this kind of function, when you run it, the next time you want to call in that particular function, it will simply ask you to put in 3 arguments. So, for instance, if I call the function var, now, you see that on top there, they will ask you to bring an argument. So you have to have the A value, the B value, and the C value separated by comments. So if I say this, if I leave it at this point and I run, it will tell me that there is an incomplete argument. So for instance, if I run it now, it will say, you can see that there is B is missing. So I have to go back there, comma, and then add, let's say 4, and then the last one. If the last one doesn't exist, put 0. And that's what is it. That's how it is. So you can run it, and then it will simply do the calculation for you. Now, there are several ways we can do this. This one, we have 2 arguments, but here I am doing the printing at different ways. So if this kind of function, if when you put it, you are going to have a value for A square separate. That's the first value. A will be there and B will be there. Even though you are entering 2 arguments, the results are going to come in more than 2. The results are going to come in like 3. So let's say I have the area, I have the length, I have the breadth. But if you know the length square, maybe that should be calculating something. The breadth square should be calculating another thing. Length times the breadth should be calculating another thing. Length divided by breadth should be calculating another thing. So those kind of functions, it allows you to use just 2 variables, but you can have more than different output. You see? So let me write on top here. Let's say functions that you generate more output than the arguments you have. So if I come here, even though I put in 2 arguments, just 2 values, you see the results are going to be 3. You see how the results are? They are going to be 3. I could just copy the entire function here. Then I want to do the very last thing, and then we run away here. Here we could have said this A2 divided by B. Then we could have said B here too what is it, multiply by, let's say 3, we could have come down. We can do this print as many times as possible. We could also say print again and say that that place too, we are also looking for b square, let's say divided by a. Now when we have finished, you see that even though it's just one small function, but the results will come out quite plenty. So the next time you call that function, like I named it like function 1, it will ask me for only 2 arguments. So if I'm able to provide, let's say 5, and then I provide, let's say 3, it will now give me how many output? 1, 2, 3, 4. It will give me 4 outputs, and that's how it is, calculating them at different rates. That's also the kind of functions that somebody come to your facility, you measure temperature, you measure maybe another variable, maybe a temperature, the weight, the what, and then you can write a function that can print all sorts of results for you. So if I have the temperature, if I have the oxygen concentration, if I have the weight, if I have the height, if I have the blood pressure, so I cannot combine all these variables in different ways that I think into a function, one single function. And so anytime I put in those variables, it will print out the results, the entire results of the person's health, status, and then I'm good to go. Okay. Now this is the last part. Let me check whether you guys are there so that I won't be talking alone. Paulina, I hope you are not sleeping.
No, I'm not.
Okay. Oh, the guy, his internet, he has actually disconnected. I wanted to leave this one as let's say as an assignment, but I'll leave it and give you a different assignment. So what we have here is how to estimate the population of a country. I mean, we want to build a function that we can use it to estimate the population of any country. For instance, if you know the population of Ghana today, and you know the growth rate of Ghana, then you can calculate how many Ghanaians will be in the next 6 years. The N here stands for the number of years. So here is the population multiplied by 1 plus the rate divided by 100, raised to the power n. So if you know the population like this, you can build the population calculator by writing a function. How do you do that? You simply would know the variables that are there, the argument. So you have P is what is argument? You have R, you have N. Okay, so now when you come, your function is to estimate population estimation. So you could just write the, let's say you want to estimate population estimate, and then the function is going to, and then you want to have a function sitting there. If I come, I have this particular function. Then what are the arguments? I am looking for an argument of P. That's my population. I want the growth rate of the country, and of course my other argument should be N. That's the number of years that I want to estimate. When I finish with that, I'm just going out of it. Sorry. And then I enter. But already I know that this is the function, or this is how population is being estimated. So when I come here, it's not easy. So I can say my population will be equal to, then you put in those parameters, or how you want the arguments to interact. So if I come here, I know that my population, my P is my population. It should be multiplied by my, of course, if I were you, I'm not going to waste my time. We just copy it from here. Just copy whatever that is on top here, and then you come and put it there, bam. So you copy from this place, and just come here. If you are lazy to type like me, then you just put it there. But remember, it is the whole of this raised to the power n. So in between the n and this bracket, you put your shift key down and then 6. It means that it is raised to the power n. And that's all. You have put in everything that you need. When you run it, the function will run properly. The next time you now want to call the function, you can just say population estimate. Then it will ask you for the value of P. That's the current population in Ghana here, 30 million. So you can just put 30 million. Let's put realistic figures. So 30, 1, 2, 3, 1, 2, 3. Then what is the growth rate of Ghanaians is 2.8. R, so is 2.8. And then how many years do we want to estimate? We want to estimate in the next maybe 10 years what will be the population of Ghana. When I do this, if I run it, oh, okay, object error not found. Do you know, are you watching? Hello?
Yes, I am.
Do you know why the problem is?
The cup.
Yeah, exactly. We just change this place to small, and then that's all. So when we run the whole thing again, and then so run this. Why? I'm not getting the output.
Return.
Come again.
Return.
So if I put this, I don't see anything.
You didn't say.
I didn't do what?
Print.
Exactly. Thank you. Hey. Thank you. I think I'm tired.
Yeah.
Yeah. I think I'm tired. But I'm very happy that you are very keen and you are following whatever that is happening. Yeah. We needed to do this to be able to complete the function. So if I do that and then I come here, so in 10 years time, look at Ghana's population, 39 million. 39.5 39.5 million. So that would be, so you see that some of these things that we have, we see them online. What is it? Calculator, you just do. These are the things that people have done. Up to this point, any question? If not, it's exactly 5 p.m. and which means that we will have to close from here.
Thank you.
I will make the script available immediately we close. But today we will not go without an assignment. So I beg you, please, let's all write the assignment and go and try. 2. So we are going to write I want us to write a function. Let me come to the bottom to So that will be assignment 1. So let me put hashtag there. And then I will say write a function to calculate the BMI the what is it to not to calculate, okay, to calculate the weight, height, BMI, and pounds of the first 10 pregnant women. That's the assignment. By the time I send you the course, there will be another one. There will be additional 2, and then what is it? We can put our hands on it. Is it all right? Okay. So we'll leave it here, and thank you all of you for being around.
Thank you.
Okay. Bye bye.